something called percent bar models, which I really like because they're a really visual way to figure out discounts. Like if you're at a store and you find out that there's a sale, you could use a percent bar to figure out what your discount is. You could use it to figure out tip or markup, which we'll talk about in a few minutes. So let me start by having you look at some benchmark fraction percent relationships. These are just really common benchmarks that you should know. For example, 10% is the same as 1/10. So basically a percent bar is really just like on your iPod or your phone, that percent bar that tells how your battery is doing as far as how much your battery is charged. It's just like that. And what I've done, just to show you 10%, is that I've broken this bar into 10 equal sections because 10% is 1/10. And so, for example, if I wanted to find out what 30% of 50 is, then I would just take 50. 50 is my whole, 50 is my 100%. See how I'm lining up my whole with my 50, because 50 is what I'm starting with. And I wanted to know 30%. Well, I know that 10% is 1/10. So if I take 50 divided by 10, I get 5. So I know that 10% is equal to 5. So each bar, each section here, is worth 5. And so if I was looking for 30% of 50, then I'm going 10, 20, 30. Here's my 30%. This section right here is 30%. So that's 5, 10, 15. So 30% of 50 is 15. So that's a pretty simple example of how it works. Another benchmark fraction, 20% is a fifth. So you can also use that for multiples of 20%. So for example, if I wanted to find 40% of 40, for example, well, I know that 20% is the same as a fifth. So what's 1/5 of 40? What's 40 divided by 5? It's 8. So I know that 20% is 8. And if I was looking for 40% of 40, well, 20%, 40%. That would be this section right here. So that is equal to 8 plus 8, or 16. So 40% of 40 is 16. And then the last benchmark fraction percent relationship, 25% we know is a fourth. So if you were looking for 25% of 80, you know that I'm looking for a fourth of 80, so 80 divided by 4 is 20. So each of these sections is worth 20. My whole is 80. If I only wanted 25%, then I know I'm just looking for 1/4, which is 20. If I wanted 3/4 or 75% of 80, then I'd look at all three of these sections, 20, 40, 60. So that's kind of the basic use of percent bars. So now we're going to use percent bar models to do a real life problem. At a store, Owen wants to buy this scooter, and the price of the scooter is $50. When he goes to the store a second time, he finds that the price was discounted by 25%. So we're looking for the new price of the scooter. Well, first on setup, we know that the price of the scooter, the whole price, was $50. And we know that $0 would have been 0%. Okay, so there's our setup. And we know that the price was discounted by 25%, and that's one of our benchmark fractions. We know 25% is the same as a fourth. So all I'm going to do is split this into fourths, and then I can take my $50 and divide it by 4, and I get $12.50. That's a fourth, or that's 25% of the original price. So each of these sections represents $12.50. Okay, so there's my 25%, 50%, 75%. Okay, and so the question tells us that it was discounted by 25%. So we know that that means this part was actually taken off the original price. So what we actually paid was what's left here. So if you take $12.50 plus $12.50 plus $12.50, then you get $37.50. So that was the price that Owen actually paid for the scooter. $12.50 was taken off. That was his discount. Okay? Try another one with you. PacSun is selling t-shirts at 30% off the original price of $28.50. How much should be taken off the original price, and what is the sale price? Well, 30% is not one of my benchmarks, but it is a multiple of 10%, and 10% is easy to work with. So I'm going to see about splitting this, starting with 100% right here. My whole price was $28.50. So I would always start by setting up what you know. And I know that 0% would be $0. And since I know I'm looking at a discount of 30%, that's a multiple of 10, I'm going to split my bar into tenths. I'm going to start by fifths, and then split each of those in half to get my tenths. Okay, so to figure out what each of those is, I need to find 1/10 of $28.50. That's easy, I just divide by 10, and that just moves my decimal over one place to the left. So that means $2.85 is a tenth of $28.50. That's 10%. So each of these sections would equal $2.85. And I'm going to stop here just because I know the question is telling me that it's 30% off. So 10, 20, 30% right there is all I need. This is my discount. So I'm going to grab my calculator here and just take $2.85 times 3. $2.85 times 3 equals $8.55. So the question that says how much should be taken off the original price, $8.55 should be taken off the original price, and then it asks what is the sale price. Well, if $28.50 was my original, I'm going to take $28.50 minus $8.55. $19.95 would be the price that I would have to pay. I got that by taking $28.50 minus the discount of $8.55. That means my sale price is $19.95. This is the one I'd like you to try on your own. So on your paper, I would like you to draw just a rectangle like this and use the percent bar model to solve this problem. So go ahead and pause the video for a moment, and then we'll go over it. So the question was, a football is selling for 40% off the original price. The original price was $50. What is the sale price of the football? Well, I hope at first you were either thinking 40% is a multiple of 10, so you could have split your bar into tenths, or 40% is a multiple of 20%, and 20% is a fifth, so you could have split your bar into fifths. I'm going to do fifths just for something different. So $50 was the original price, that's my 100%. Okay, so 0% would have been $0. And I told you I was going to use fifths because I know that 20% is equal to 1/5. So split this 1, 2, 3, 4, split it into fifths. My original price was $50, so if I divide that by 5, then I know that each section represents $10. So here's 1/5, 2/5, okay, and it was 40% off the original price. Well, here's 20%, and here's 40%. So what I'm looking for is this section right here. $20 is what's going off the original price. So what I'm actually paying is right here. So what is the sale price of the football? It's $30. I'll be paying $30 for that football. Okay, this next problem is about something called markup. Basically, when a store gets an item and they sell it to you, they don't sell it to you for the same price that they got it at, because then they wouldn't be making any profit. So now we're going to look at some problems that go beyond 100% because the store has marked up their price to make the selling price for you. So basically, we have a phone case that is marked up 20% on the original price. The original price was $30, and we're looking for what is the selling price of the phone case. Well, we still set it up just like always. We know our 100% is the cost of the phone, which is $30. 0% would have been $0. And we know that has been marked up 20% on the original price. So we can start by finding 20% on the original price. But we know that our selling price is actually going to be beyond $30. It's going to be more than $30 that they sell it for. Since they're selling it for 20% above the original price, that's 120%. And so that's what we're looking for as the final answer to our question here. But we do know that 20% is equal to a fifth. And so I'm going to start by taking my $30, dividing it by 5. So I know that 1/5, or 20%, is $6. Okay, so the phone has been marked up 20%. Well, if this is my 20% right here, I know that this extra 20% at the end is also $6. And so the original price was $30. I'm adding on 20% for the markup. So 30 plus 6 is $36. So when it asks you what the selling price was of the phone case, it's $36. Okay, we just had to add on that extra 20%. Let's try another markup problem. Now we're going to get into some percents that are not as simple as the ones we've been working with. We've been working with nice benchmark percents, and sometimes they're not always so nice numbers. And what this says is you can always divide down to find 1%, and I'll explain what that means right now. A $60 shirt was marked up 18% and sold over the internet. How much was it marked up, and what was the new price? So this is a lot like the last problem. We know that the price of the shirt is $60. So 0% would have been $0. And we know it's going to be marked up 18%. So the final selling price of the shirt is going to be 118% because it's bigger than the original price. Okay, in red it says you can always divide down to find 1%. This will always work. If you're on a percent that's not an easy number to work with, you can always do this. Because if you know the 100%, you know that 100 divided by 100, any number divided by itself is always 1. So also, scale factor that we've been working with fits into this type of problem, because if you take 100 divided by 100, that's going to find you the 1%. But if you take 100 divided by 100, you also have to take 60 divided by 100 to keep it balanced, just like scale factor. So 60 divided by 100 would move your decimal point over 2 places, which would make it 0.6 or 60 cents. So 1% is 60 cents. How does that help us? Well, now that we know what 1% is, we can just use a scale factor of 18, multiply it by 18 to get what 18% is. So that's exactly what I'm going to do here. I'm going to kind of estimate 18% is about here. If I know 1%, I'm multiplying by 18 to get 18%. So if I know 1%, I'm just going to multiply by 18 to get 18%. So here's where I could grab my calculator. And I know that 0.6, 60 cents, times 18 equals $10.80. Okay, so I know that this shirt is going to be marked up by $10.80. So this little section right here that I'm adding on to get to my 118% is just where I need to take 60 plus $10.80, which is $70.80. So $70.80 is going to be the new price of the shirt. Okay, so just remember, if it's a percent like this that's kind of difficult to work with, divide down to 1% and then just multiply back up to whatever you need. So, all right, here is another problem dealing with markup. A car dealership advertises a 7% markup over cost. Find the selling price of a car that cost the dealer $13,000. Okay, the dealer paid $13,000. They want to make a profit, so they have to mark up the cost for you. So let's start by putting what we know. We know that the dealership bought the car for $13,000. Okay, 0%, $0. We know that there is a 7% markup. Once again, 7%, not an easy percent necessarily to work with, but we can always divide down to 1%. Remember that 100 divided by 100 equals 1. So if you take 100% divided by 100%, you're going to get 1%. And if you take 100 divided by 100, you also have to take 13,000 divided by 100. That's going to move my decimal 2 places over, which means that 1% is $130. Okay, and if I know that 1% is $130 and I want 7%, just use that scale factor of times 7 to get to 7%. Times 7 here, you have to do times 7 here. So 130 times 7 would get you your 7%. So 130 times 7 equals $910. So we know that the dealership is going to mark up the car $910, and we're looking for what the selling price is. So that will get us beyond the 100%. This is going to take us to 107%. And so if you take 13,000 plus 910, that of course gets you $13,910. That would be the selling price of that car. Okay, I would like you to go ahead and give this one a try on your own. Use the same method that we've been doing when you have a percent that's not so easy to work with. Go ahead and give this one a try and we'll go over it in a minute. Please pause the video. Okay, so James buys an Xbox game for $35.99. The sales tax in his area is 8.25%. What is the total price he'll pay for his game? All right, well, we know that the price of the Xbox game was $35.99. Okay, so 0% would have been $0. 8.25%, not an easy number to work with, but we know we can always divide down to 1%. So if I take 100 divided by 100, I get 1%. But if I take 100 divided by 100, I have to take $35.99, also divided by 100. And so that 1%, and I know this is going to look strange, but I'm going to keep it exact right now. Remember I told you that you never round an answer until it's your final answer. You want to keep numbers exactly as they are until you get to the final answer. So 0.3599 is my 1%, but I'm looking for 8.25%. Don't let that decimal mess around with you. It's just the same way as if it was a whole number. To get from 1 to 8.25, you multiply times 8.25, which means you also have to multiply here times 8.25%. But, of course, 8.25%, oh, okay, so sorry. I'm going to go ahead and multiply times 8.25. Let's see. So 0.3599 times 8.25 equals 2.9, approximately 7. So $2.97 is going to be the tax that needs to be added on top of the original cost of the game. So if I extend my bar here, I know I'm getting to 108.25%. And if I go ahead and add my $35.99 plus my tax of $2.97, I get a total cost of $38.96. So what is the total price he will pay? There you go. That's with tax added in there. So I hope you like the percent bar model method. I think it makes it really visual. Hopefully now you're not just doing steps to find an answer, but you actually understand what you're doing to get to your final answer. I think that's my last question. Yes, it is. Thank you.